Tell me first, what happens if all the vehicles on the road start driving without laws or rules? That is, no stopping at red lights, no specific lanes for cars and pedestrians, and no ban on honking and rash driving. The answer is evident. There will be a massive traffic jam. Imagine what chaos will occur on the road. Similarly, while making chemical compounds, some laws have to be followed. Imagine if there were not any laws of chemical combination, then I suppose we wouldn't be having any washing powders, soaps, medicine, and many other things that have become a part of our routine in today's time. So, some laws must be followed while combining chemical compounds. Which brings us to the discussion of the 5 laws of chemical combination. Let us start with the law of conservation of mass. This law was put forth by Antoine Lavoisier. After performing several experiments, he concluded that there is no net change in the mass in all the physical and chemical changes. Thus, this law states that matter can neither be created nor be destroyed. To understand this better, let us take a general example first. We have seen that a log of wood requires oxygen for burning and then changes into charcoal, ash, and soot, and it also releases some gases into the atmosphere. Now, suppose we measure the weight of the charcoal, soot, and ashes, and let us presume that we also know the weight of the gases. In that case, the combined weight of all the residual substances will be equal to the original mass of the piece of wood and the oxygen before burning. Let us now take the example of a chemical reaction. If heating 12 grams of calcium carbonate produces 5.4 grams of carbon dioxide and 6.6 grams of calcium oxide, let's check whether these observations agree with the law of conservation of mass or not. Here, the mass of the reactant, that is calcium carbonate, is given as 12 grams. And the mass of the product is equal to 5.4 grams plus 6.6 grams, which is also equal to 12 grams. Therefore, according to the law of conservation of mass, mass of the reactants is equal to the mass of products. Hence, this example of a chemical reaction agrees with the law of conservation of mass. Now, let us move to the second law, that is, the law of definite proportions. This law was given by a French chemist, Joseph Proust. He said that a given compound will always have the exact composition of elements irrespective of the source. Thus, this law states that a given compound always contains the same proportion of elements by weight. For example, the chemical composition of water is 1 atom of oxygen and 2 atoms of hydrogen. The atomic mass of the oxygen is 16 and hydrogen is 1. That means water consists of 11% of hydrogen and 89% of oxygen. This is the chemical composition of water. There is no other way of creating water. Now, if you take 2 samples of water from 2 different sources like pond water and tap water, if we study the chemical composition of both the samples, we will find that the chemical composition of water is the same for both samples because 16:2 is the fixed chemical composition of water. It will not change according to the source. Moving on to the third law, that is the law of multiple proportions. This law was proposed by Dalton in the year 1803. It states that if 2 elements can combine to form more than one compound, then the mass of one element that combines with the fixed mass of the other element are in the ratio of small whole numbers. Let us take one example. We all know that hydrogen and oxygen combine to form water and hydrogen peroxide. Now, in both the chemical reactions, oxygen combined with a fixed mass of hydrogen, the ratio of oxygen is 16:32, or we can say 1:2. Hence, the law of multiple proportions is followed in this reaction. Next, let's discuss Gay-Lussac's law of gaseous volumes. This law was given by Gay-Lussac in the year of 1808. This law states that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all the gases are at the same temperature and pressure. For example, if 100 ml of hydrogen combine with 50 ml of oxygen to give 100 ml of water vapor, thus the volumes of hydrogen and oxygen which combine, that is 100 ml and 50 ml, bear a simple ratio, 2:1. Next is the fifth law, that is Avogadro's law. Amedeo Avogadro gave this in 1811. This states that equal volumes of all gases at the same temperature and pressure should contain equal number of molecules. If we consider again the reaction of hydrogen and oxygen to produce water, we see that 2 volumes of hydrogen combine with 1 volume of oxygen to give 2 volumes of water without leaving any unreacted oxygen. Here, each box contains equal number of molecules. Let us move on to our final concept, which is Dalton's atomic theory. In 1808, Dalton published a new system of chemical philosophy which had the following points. Matter consists of invisible atoms. All atoms of a given element have identical mass. Atoms of different elements differ in mass. Compounds are formed when atoms of different elements combine in a fixed ratio. Chemical reaction involves the reorganization of atoms. They are neither created in a reaction nor destroyed. Dalton's theory could explain the laws of chemical combination. However, it could not explain the laws of gaseous volumes. It could not provide the reason for combining of atoms, which was answered later by other scientists. Now that we are familiar with the terms atoms and molecules, I will now give one question to think about and discuss. The question is, what is the meaning of atomic and molecular mass? This concept will be discussing in the upcoming video. Now, we will summarize whatever we have discussed in this video.
Manorama Horizon. Learning made simple.